Okay. So, hey guys. So this is really a workshop in the sense that I was hoping that I'm going to show you a workflow, hopefully using a system that we have built that you'll find useful. Of course, I'll start off by explaining why it's useful, and then take you through a feature engineering exercise, right? Again, as Franklin said, this is long time ago. I used to be a faculty at Georgia Tech. I used to teach both the undergrad and grad AI course at Georgia Tech. I was not faculty for a very long time because I started a company and then left, but most of my PhD students who graduated at that time worked with me, also worked on AI ML. So this, clearly the roots of this go back a long time. So I'll take you through this. Now I'm going to assume that this is a very nerdy presentation, of course, and I'm going to assume that this is a very nerdy crowd, right? So that's the basic assumption which I'm making, and I'm going to be walking you through a open source package called Anovos. You do not necessarily have to download it and work sort of on it with us, but if some of you did, that would be good. Varun is going to handle the notebook part of it. We're going to show you, and if you could execute some of the instructions and see the result. The package and the data has been made available through Docker. I think the app has the location of. But it is not necessary that you do it because we'll show it to you here as well. But I thought that if you did it, that kind of gives a different feel for the experience, right? So again, let's start. So first, what I'm going to be doing, and just to this is, in GitHub you can find Anovos there. Clearly, we have there is a Slack channel, and so we have a fairly large group now that is global called Feature Engineers, where we do a bunch of things as well. So this is the, my head of marketing made sure that this slide was shown to start. So we have shown this slide, and we can go on now. So this is what I'm going to be doing. I'm going to be presenting, so I'll frame the problem and frame what I'm going to show you. And the first, 3 slides is that framing, right? Which I will look at you and do it from here. The next bit, which is the bulk of the time, is a structured walkthrough in a Jupyter notebook. That, of course, I can do it. I sometimes do it standing here, like in a classroom. It gets all over the place. So I'm going to go sit there. I have some notes exactly what he's going to show. So hopefully, I'm not going to be looking at you when we're going to be doing that. But absolutely, stop us, ask questions. In fact, what I'm hoping is that even if we get 1 or 2 fans of this here, we want contributors as well, right? So just to let you know, this is being used in, for instance, the entire data pipeline at AT&T is implemented on Anovos right now, right? Then I don't know if you guys have heard of a company called Symphony.ai, which is, of course, one of the largest AI, Symphony. So there's some very cool users of this as well. So hopefully, this is not a sales pitch. Criticisms are welcome. Condemnations are welcome. And of course, participation is the most welcome. So with that background, let's start. So here I'm going to show you, again, this is a slide from my lecture notes almost 20 years ago. Right? So this is basically, this is the flow of building and operating a model. Again, there could be other takes on it, but this is kind of what happens. So you start off with, of course, base data. I'm going to build a model. I work in a company. There is some data, CRM system, subscriber system, subscriber database for a telecom. So I first pull in, or the data comes in. It comes in batch. It comes in as a stream. However, it comes in. And one of the first things I do when I'm building a model is I try to assess what is the suitability of this data or different attributes of this data. Let's just assume we are talking about a tabular data set. We don't have to, but makes this exposition easier. So basically, I'm looking at attributes and seeing how are these individual data items, what's their suitability for modeling, right? So all of you guys know we perform EDA. And an easy way to understand EDA, at least for me, is that we run through this loop of analyze, assess, and treat. And each step we ask a question, right? Hey, I pull in a column. How many missing values? Assess health. Hey, too many missing values. Treat and clean. What do I do? Do I throw it away? Can I save it? Do I impute it? And same, bias. I go through this cycle, fairly well-known cycle, right? Of properties that I check. I understand how those properties play out for my data, and I decide to do something, either throw it away or do something, right? And then what comes out of this stage is clean, modelable, clean data suitable for modeling. And of course, all of you know that data in the form that it exists in enterprise databases is generally not consumable by models. You need to convert this data to these specialized artifacts called features, right? So then I entered the feature creation phase, right? So I have clean data. The feature creation phase itself, you can think of sort of three broad steps, right? The first is candidate feature generation. The first thing that people think is, I'm trying to predict something, right? I mean, I am MetLife. The travel insurance marketing people at MetLife comes to a data scientist and say that, hey, I want to acquire buyers of our travel insurance, right? I want to run marketing campaigns. Who should I target, right? Can you build me a model for propensity to purchase travel insurance? Who's likely to do that? The first thing in the feature creation phase, the data scientist, the modeler thinks is, what is even predictive of buying travel insurance, right? And she may think, well, I mean, if you don't travel, you really wouldn't need to buy travel insurance. So maybe propensity to travel. If you travel a lot, that's predictive of buying travel insurance. So they might think that, hey, travel insurance is usually a cost that is tacked on top of your ticket price. So that increases cost of the travel. So maybe affluence is a predictor of buying travel insurance. And they would go through this step, and eventually, so these are candidate features, right? These are the high-level predictors that they believe would be predictive of the outcome that she seeks to predict, right? So you go through that, and you come out with, okay, here are 20 things that I think might be I don't actually know yet if there will be or not, but I think there might be, right? But this thinking led you to only feature labels, right? He thinks, hey, affluence is predictive. But I still need to create those features based on the data I have, right? So you may say that, of course, in the case of this travel insurance example, the data that this modeler has is the database of all the insurance policies that MetLife has sold, millions and millions of travel insurance policies. They have this data. And of course, clearly, affluence is not a column in the database, but they might say that, hey, I see the zip code of the person who bought it, and knowing the zip code, I can find the average house price there, and maybe I can use that as a proxy for affluence, right? But bottom line, that data that I brought in has to be mapped to these predictor features, right, to start. And one of two things might happen, Varun, if you want to animate one more. You may see that, yes, I have something in my base data that I can use to create a proxy for this feature. Or, imagine I told you that something that might predict propensity to purchase travel insurance is if, hey, does this person travel? Unlikely that anything is there in that data that shows how often this person travels, right? So the other thing that might happen is that you might say that, there's nothing in my data that can let me create this feature, in which case, the little green thing, you can go and say, can I acquire that outside, right? Can I acquire data or this feature outside? But bottom line, you generate this predictive feature, sort of thinking what might be predictive. You create those features from the data you have, or you get additional data. And then basically, at the end of the data to feature mapping phase, you have your full candidate feature set, instantiated feature set. And then, you do sort of what we call final treatment, right? You might do dimensionality reduction. You might do, you do transformations. You do a variety of things, well-known things. And after you do that, what comes out are your model-ready features. So those are the things that I'm going to use to build a model with. And then, these days you typically store it into a feature store. You could do something else with it, and then sort of you get into the model pipeline phase, right? You take a variety of techniques, train it on these features, see what works. If something exceeds your threshold KPIs, you build a model, you deploy it, keep going, and then the model is running, and you get the operational feedback, right? So this this for me is a fairly detailed way of building and operating models. Right? And the only thing here is, the blue arrows kind of represent the data pipeline part, and the red arrows kind of, and without any doubt, because, I'm a data pipeline guy, I have clearly blown that up, and I have abstracted away a lot of the model pipeline. Clearly, there's a lot goes on there. But bottom line, that's roughly what happens, right? And if you do one more, I think the problem here is this. Basically, what you would have seen is something that covers everything from here to there, and that's what's known as feature engineering. Somehow the coloring. So that and you guys know this, that whereas most of the stuff that you see, and I'm sure that I didn't go into the sort of the booths that were there. Most of the stuff, a lot of the work that is going on is in the model pipeline and MLOps part, right? The data pipeline is still super ad hoc. It's left up to the modeler. It's sort of super messy. It's very subjective. It's very error prone. And so it's generally accepted that feature engineering is sort of a very subjective step, right? So if you think of available tooling in feature engineering, clearly there is stuff that people use, for sort of the EDA parts, right? Ingest and analyze and the final treatment. There are a whole bunch of things available that you can go check missing values. You can go check bias. You can, create variable clustering. You can check attribute association. Pandas, for instance. But it still is manual. I mean, the modeler takes package, says, okay, run this. Okay, this happens. What do I do, right? So it's sort of super manual, super subjective, and very modeler driven. On these two, which are some of the hardest problems in feature engineering, there's no tooling at all. It's completely ad hoc. The thinking of what predicts is totally ad hoc, okay? And because the choices you make especially at this step, kind of will ripple through the entire process, right? They end up being massive impactors of your eventual model quality, right? How accurate is my model? How resilient is my model? And so on. And of course, as you know, there are a bunch of feature stores now, of course. And there are almost no offerings sort of on third-party data and features. So this is the state of feature engineering. So now let me frame you. So what we have, and again, this is not a commercial offering that we have, right? So because at Mobilewalla, we build a lot of models. So we have about 130 models in production. The amounts of data that we get in is quite large. We have found that this has been a hugely problematic part of our model building scenario. So internally, and the team at Mobilewalla itself is sort of super, the guy that runs it used to be one of my best PhD students from a long time ago. So it's a very science experiment-y kind of team. So over time we have built, little component here, little component there. And as we have done that, and as that has kept helping sort of our own stuff, some of our large clients, and so we have massive financial technology clients, we have very large telecom clients. They sort of said that, hey, why don't you let us use it? So they started using it, and then finally we said, hey, let's just put an open source package together and launch it, right? So basically what we've done is we have proceduralized this part, and I'm going to walk you through it. So that's the framing of what I'm going to show you. Does that make sense? Okay. So now I'm going to go sit there, guys, simply because doing this part extempore is like hugely difficult because there are like 3 zillion things that I have to remember. I'm going to sit there. I have little notes. But bottom line, what I'm going to take you through is feature engineering for a specific modeling scenario, right? And I'm going to take you through using Anovos. For those of you who have got the Docker image loaded, you can sort of follow along. And we'll tell you sort of, if you don't, you can just follow along here. Make sense? All right. So this is, I kind of already explained this to you, Varun, so you can skip that. So basically what we'll be doing is showing you Anovos. Anovos is, as I told you, is an open source library sort of that enables scalable feature engineering. So we are, and again, based on the framing that we had before, Anovos was created with 3 goals, right? So Varun, so first goal was to proceduralize feature engineering, right? Again, I showed you majority of the steps are super ad hoc, trial and error, and makes them very vulnerable to mistakes. So we wanted to proceduralize, right, and reduce that. And the contribution here is not so much that we are inventing something radically new, no. But we are orchestrating things. We are making an inherently ad hoc process systematic and simpler. So that's the goal. The second was to add entirely new capabilities, which I'll show you. So there are some we think we have solved a few of the hard problems here. In fact, we'll show you the notion of data stability. We'll show you something that we have introduced called a feature recommender, which takes away the cold start problem, right? So in Anovos, the MetLife data scientist could say, hey, I'm trying to build a model to, the outcome is propensity to purchase travel insurance. What features can I use? And that gives you features. It's like a hugely useful thing. So I'll show you that. So there are a few, yes? No. So it does not at all. So we have, in fact, we'll show you some examples of that. You can play with that and so on and so forth as well, okay? And then the last, that's going to be difficult to show here, but the goal was to enable scalable feature engineering, right? I mean, if you look at most of the stuff that people are using now, like pandas, right? I mean, you guys know it's single-threaded, sort of in memory. It just doesn't scale when you have meaningful amounts of data. We do, so for instance, at Mobilewalla, we are ingesting 100 terabytes of raw data a day, right? So we have it stored for 7 years. The underlying raw tonnage, I think, is like hundreds of petabytes, almost exabyte scale, right? Now, it's not like we are pulling all of that in, but the data we are using is pretty high. So we wanted to enable, distributed feature engineering. And so the way we've done that is that Anovos runs on Spark. So it's one of the first sort of, at least, I don't know others. It's one of the first sort of distributed feature engineering systems to run on Spark, right? We are, over time, you'll see other, I don't know if you guys have heard of Ray, so Anovos will support other distribution frameworks as well, but right now it's Spark. So in this demo, what we'll show you is building a credit risk model, right? So the goal is to predict the credit worthiness of somebody who applies for a loan, right? So I can tell you some of our customers. So I don't know if well, some of you must have heard of companies like Paytm, BharatPe, Credivo in Confio in Mexico, Credivo, these are all unicorns that are lending to so those are the places where this kind of modeling would be used. Somebody applies for a loan, they don't have credit footprint, so you're going to use AI to build a risk model, right? So that's the scenario. And basically the prediction is a credit score, which is the ability of the applicant to repay the loan, right? The base data set is taken from Kaggle. So we are showing you the data set. We did not use one of our clients' data sets, of course, but luckily Kaggle has one. But you'll see, I'll point out, but we have tweaked it slightly for some of the use cases because it's not quite, some of the things in ANOVOS requires a little more complexity, so we've introduced that. I'll describe that to you. So Varun, if you go, so this is the data set, right? So so this is the Kaggle data set that we are showing you. It's a table. You can think of this table having 3 classes of attributes. The first is a application ID, loan application ID. The second is a group of descriptor attributes, right? That describe characteristics of the loan and the applicant. And the third is a target variable. Now, so basically here I'm showing you the example of a supervised learning. You can use ANOVOS for unsupervised as well, okay? But in this case, we're showing you a supervised example, right? And you don't have to go back. Well, all I was going to say is the target variable, this is a binary variable, right? So 1 if the loan had issues, 0 otherwise, and so on. So now I need to look at this. Okay. So bottom line is using that data set, the modeler is going to build a risk prediction framework. And the broad workflow is going to be as follows, right? So Varun, so we're going to pretty much what I showed you earlier. We're going to do EDA, right? We're going to see the attributes, and then I'm going to do the feature identification, basically generating features. And then I'm going to do the final steps. And all of it we're going to do using ANOVOS. So let's first move on to. So we'll first start by ingesting the data set. So Varun, if you open up the notebook. So the first step is loading. And again, you guys I'm going to go slightly slower, so those of you who are doing it can actually run the command. So basically, that's the load command, right, in ANOVOS. So you load the data. And of course, once you load the data, the data shows up. Of course, too complex to understand. So ANOVOS has, we believe, sort of very powerful capabilities to explain this, to have you look at the data. So this you can do in ANOVOS in 2 ways, right? So one is you can do it using the notion of reports. You can use something called ANOVOS reports. And the second way you can do it is calling functions directly from ANOVOS data analyzer module, okay? I'll show you both. So first is report, right? So here are the commands. So you can generate 2 kinds of reports in ANOVOS, basic and full. So there are and here do not execute this command because this takes a little time. So just for this command, those who are doing, yes? Can you, yeah, I heard her. Zoom in, to zoom in. Is that better? So those are the commands to run the basic and full reports. Do not run the command, actually, those of you are doing it, because it'll take a little bit of time, a few minutes. The other commands, all the other commands that we're going to show you, run them. And I'm going to take you through. So we have a canned, which you have as well. I have a canned full report available that I'll take you through, right? So Varun, if you'll open up the report. Okay, so this is what an ANOVOS report looks like, right? So it's a report that has 6 tabs. The first 2 tabs are really, and I'm going to have some points as to what I want to say, okay? All right, the first 2 tabs is really meta information, right? If you show the first tab, the first tab is a summary, right? The second tab just contains all the data types and the inputs. It's really the last 4 tabs that is content rich, that is information rich. So we'll go through them in detail. First is descriptive statistics. So using descriptive statistics, if you will go to descriptive statistics, so we can first see global summary of the database, including number of records and number of attributes. The first thing. Okay. So the first thing that the team, that we recommend teams look at is sort of missing percentage, right? So we are looking at measures of counts. The first thing, we look at missing percentages. So you can see that under descriptive stats, you have this sub, measures of count, measures of central tendency, measures of cardinality, and so on. So the first thing we usually recommend people look at is missing percentage. So Varun ordered by missing percentage, and you can see that the attribute common area median has over 70.5% of its values missing, right? You can see the others as well. In general at Mobilewalla, when something is more than about 0.65, 65% missing, we throw it away, or you could decide to do otherwise. So we would typically throw it away. But I just wanted to show you missing value analysis, right? Let's go to measures of central tendency. Another measure that is super useful is mode and mode percentage under measures of central tendency, right? And basically, as you guys all know, this shows you column skews, how they're skewed, right? So for instance, Varun, if you order by, let me see the example I had. If you order by mode percentage, you can see that the attribute flag count mobile has almost 99% of the values to be 1, right? So clearly, its information, and this is for the real data, right? Its information content is not very high, and in general, we would throw it away, right? I'm just showing you one, but you can see all of them. Personally, I find measures of percentile sort of super useful as well. Right? If you go to measures of percentile, and basically it reveals whether there are any extreme values or not, like outlier detection, right? So extreme values or not. For instance, Varun, did you order by attribute column? Okay, you did. So you can see my practice with him was useful. So he's doing it before even I'm saying it. So if you order by attribute column, you can see amounts like amount annuity, amount credit that are related to amounts of money. So we can observe a huge difference when if you scroll right. So you can see that there's a huge difference between the 99th percentile and max value, right? So of course that tells you that there are outlier treatment would be necessary for those, right? So at the end of this tab, by the way, I should have shown this to you before. Each thing I'm showing you, there's visualization as well. Right? So if you scroll down, there is visualization of those as well. Let me see what I point. So we are showing you histograms for both numerical and categorical attributes. Clearly, amount credit is a numerical attribute. Varun, why don't you show name, income, type? That's a little more. So in the categorical attributes, you can see that so we show you both the tabular and the visual representation, right? So basically, what I was doing until now was showing you, we are checking quality of data, right? Missing percentage, skew, outliers, and so on. And what I was doing is I was showing you one by one, right? Hey, if I check missing percentage, what happens? If I check this, what happens? So experienced data scientists, of course, might follow that path because they know sort of exactly what they want. But what most modelers will find super useful is an automated quality check, right? That does all of this, and presents the information in a consolidated manner. You didn't have to do this one by one. So we make this available in Anovos in the quality checker tab, right? So that's an automated quality check that has done all the checks, right? So the quality checker, don't scroll yet, just the quality checker basically reports quality issues along 5 dimensions, right? Null detection, IDness detection, or if you just check, biasness detection, invalid entries detection, and outlier detection, right? So clearly, we don't have time to take you through all of these. Let me show you one. So let's show them biasness detection. If you go to the biasness detection, yeah. So in the descriptive stats tab, if you remember, we saw how we looked at mode percentage under measures of central tendency to see column skews, right? So here you can see biasness detection leverages that information automatically and flags such highly skewed columns, right? So you can see, I showed you that flag cont mobile came up very skewed here. It's automatically showing you here, right? And all of this, likewise, idiness detection leverages cardinality measures. Outlier detection leverages percentiles and dispersion measures and so on, right? So it's basically giving you full quality check automatically, right? So, and again, I mean, these are just a few examples I'm showing you, but basically what the quality checker has is a comprehensive list of quality assessments that data scientists need to perform at both row and column levels. And so we believe that this automated quality checker is a key differentiated ability. Now, you can do all these statistical checks using packages, right? I mean, you can get a package and say, do this. You can get a package and say, do this, right? But they need to be done manually. The modeler needs to explicitly ask for them to be done. But here, what we did was we automatically orchestrated, what ANOVA automatically orchestrates comprehensive set of quality checks for you and shows it to you, right? So the next one will move, is one of the most something that every data scientist does, which is check for associations between attributes, right? So here we are showing you the capabilities that ANOVA provides to automatically reveal attribute associations from multiple dimensions, right? So let's look at, so we'll show you the, Varun, can you do the drop down just for a second? So there are 4 ways in which we show you, ANOVA shows you attribute associations: correlation matrix, IV, information value, information gain, and variable clustering, right? So let me just give you a sense. So let's look at correlation matrix to start. Again, this is showing you pairwise association, right? So let's pick one. Let's say, amount goods price, which is the 3rd row, and amount credit, is 0.95 association, right? So clearly you don't need both, right? So it shows you almost every data scientist used to seeing correlation matrices, so that shows you, right? So moving on, let's look at other, right? So let's look at analyzing associations from the information value perspective. By the way, in financial technology, information value is used a lot, right? So for instance, for this thing, information value ends up being used a lot. So under IV calculation, if we order by, when did you order by the column IV? Yeah, so if you order by the column IV, we can see that attributes related to external source, right? You can see the top 3 are external source attributes, are the ones containing the most information value, right? So at least from this analysis, you would walk away with the sense that, hey, either these are important features, could be important features by themselves because they have such high information value with regard to predicting the target variable, or you would think that eventually the features that I'm going to create will take this as input, right? That's the sense you would walk away here from. And very similar analysis can be done from information gain as well, right? So if we did information gain, you would see that. The final technique, of course, is variable clustering. Again, you guys know that variable clustering is computationally a bit more expensive, so it takes longer to run. And if you're using cloud, it's going to cost you a bit more. But it's a great alternative to correlation matrix because correlation matrix gives you pairwise associations, whereas this is giving you group-wise associations, right? So here I have a note. What did I want to show you? So you can see, and by the way, I also have a note that in a later section you'll see there's a very powerful section for powerful technique for dimensionality reduction as well. We'll see that later. So in this case, you can see 4 attributes related to amounts of money, amount credit, amount income. The first 4 all are cluster 0. It's grouped into one cluster, right? So you know. And again, there are packages that provide these functions individually, right? You can go run information value. Though we haven't come across one that consolidates all of this into sort of one framework, right? And the power of ANOVA is the availability of these diverse techniques all in one place. So now we'll go to the final. By the way, there are some very interesting, what we think are very cool visualizations as well, where you can see the associations visualized. So now we'll take you to a new contribution in ANOVO, something called drift and stability, okay? So drift, of course, you guys all know. In drift and stability, there are two sort of things. First, we'll show you drift analysis, and then we'll show you stability analysis. And here, stability is something that we have created, right? So those of you who follow towards data science, you can go look up my name. So I have an article there on drift and stability, which a bunch of people sort of have interacted with me on, and talking a little bit about the science underneath, the math underneath that. So in drift analysis, I mean, this is, all of you know this. Drift, of course, is one of the most common causes of lack of resiliency in models. So, but the way drift is usually checked is post facto, right? I mean, you have your model, the model misbehaves. One of the things, the first principles analysis you do to figure out why it misbehaved is you check, hey, is there a drift in my input, right? So we are showing you here. So what we have done here, by the way, to report drift and stability here, so we have changed the Kaggle, or we have enhanced the Kaggle dataset in the following way. The Kaggle dataset is actually one snapshot. It's one table showing you this is the result now. So we have generated sort of historical snapshots. Basically, we have simulated and generated a bunch of history. So imagine that report is taken out once a month. So we have generated the version of the report that would have existed in M-1, M-2, M-3, M-4, and so on, right? So and we are showing you based on that. So basically, this compares drift between two data sets. You can say, hey, which data set do I want to compare to? You might say, compare my drift to data set M-12, for instance, right? And it's showing you, and those four are distance measures, very well-known distance measures, and we are showing you that hey, higher the value, the larger the drift. Now, the drifted attributes flagged by ANOVOs, and here I want to show you something, includes 3 attributes related to external source, right? So you can see that external source 3 and external source 2, for instance, have drifted, right? So the reason this is interesting is that when I was showing you attribute associations and I showed you what came out of information value, it came out that this external source attributes had high information value. So just that analysis would appear to indicate to you that these would make good features, right? What I'm telling you here is that yes, they had high information value, but they also drift a lot, right? So that means that you can use them. The model would likely, if you use them, the model would likely be very predictive, but it might also have undesirable resiliency properties because of this drift, right? So one of the things of ANOVOs that they're used for is to understand this dichotomy and these trade-offs. And now we come to data stability analysis, which is actually a first principles innovation. So in stability, so let me show you sort of, and Varun, if you go down, we let you visualize as well, right? Which columns have drifted and so on. So data stability is sort of, at least for me, is super interesting, right? The point of data stability is that drift gives you a point measure. So how is my data now different from data some time ago? But imagine if I was able to take the first derivative of drift, right? Drift to dt. How is my data drifting over time, right? So stability is the longitudinal measure of drift. And you can think of stability, the stability value of a data item is basically giving you the driftiness of the data item. The other way to think about stability is a predictor of drift. So stable values are likely to drift, unstable values are likely to drift in the future. Stable values are less likely to drift in the future. And they become like super, this using in our models and some of our clients' models have totally changed the resiliency properties of the model. Before, our average model update time was something like 27 days. Once we have started using stability as a marker for model building, it has gone to 60 days or something. It's been sort of super useful, right? And here, again, I'm happy to sit with you afterwards and give you the math of stability. Basically, stability is a function of three properties: the kurtosis, the skewness, the kurtosis, the standard deviation, and so on. But here, just basically, if it's a variable that goes from 0 through 4. 4 is very stable, 0 is very unstable. So the lower the value, the less stable it is. The higher the value, the more stable it is, right? And you can see, for instance, that, so we are showing you all the stabilities. Apartments MEDI, which is 2.6, is a relatively unstable attribute. Basement area median, 2.1, is a very unstable attribute, and so on, right? And then if you go down and show them so this is showing you that what's the average stability, how many attributes are stable, how many attributes are not stable. Go down. And stability is basically a convolution. The math of stability is a convolution between mean and standard deviation and kurtosis. Okay? Those are the three essential properties of a distribution that we found is predictor how stable it is, right? So that's a first principle kind of innovation in ANOVOS. All right. So now let's head back to the notebook form. So this is the report. Again, I showed you very few things, but you get a sense of how it reveals a very significant sort of property set of your data. So you can choose to use the report, or you can call those functions by yourself. So ANOVOS has a fairly rich data analyzer module, and here you can follow along by calling the functions yourself. And so you can do all of that by yourself. So clearly, I'm not going to show you all of it. Let's show you outlier detection. Okay. So again, why outlier detection? Manually detecting outliers is super hard. I mean, if the data set is small, you can kind of look at it and see it. But for a large data set, it's sort of very hard, and it's practically infeasible at meaningful scales. So what we'll show you here is sort of our quality checker module for auto detection of outliers. Right? So one of the things of ANOVOS is that you don't need to apply these functions on all the attributes, right? I mean, it's nothing. I just wanted to point it out. You can select which attributes to apply the function on. So you can see that I'm calling this function on, and our default config, by the way, is applied in all the functions, but you can go change that. For outlier detection, so you can see there is something called a list of columns. To this list of columns, basically I'm saying that only apply outlier detection to attributes that start with days. Basically, all the days attributes are counts of days, okay? Time-related attributes. So that's what I'm doing. And Varun, if I show, you can see clearly here, you can see this is the output. And all the values should be negative, by the way, because all the values is now minus something, right? So when you're born, so all the values should be negative, but you can see that some aren't. For instance, the positive values in days employed, right, are invalid, for instance, right? Day's birth is the applicant's age. If we look at the minimum value of that, it's like greater than 150 years, right? So that is clearly incorrect as well. Days last phone change when the user changed their phones, it's like 10,000 days, which is like 30 years. That's also incorrect. But all of these is manual observations that we are making, right? So we are looking at it. Of course, I'm pointing them out to you, sort of super difficult. So instead, we will use the quality checker outlier function, right? So in this, we have developed an ensemble technique which takes multiple statistical methods into account. I'll tell you what they are for detection purpose, right? So again, I'll tell you what they are. This is again a key capability differentiator in ANOVOS, right? So we are not aware of, and I'm just showing you outlier detection, which almost everybody does. I mean, we have this for everything else. So we are not aware of other proceduralization like this. So Varun, let's apply that. So as we saw, again, through measures of percentile results earlier, we saw that outliers seem to exist on both ends of the spectrum. So we will use both as argument to detection side. Basically, I'm going to check for both. And we'll also opt to treat them right away. Now, again, you can provide treatment options. Here, just the treatment options we are putting in here is just replace outliers by null. Right? I mean, that's what we are saying. You could have others. And so once I execute that, for those of you who are doing it can execute that on your own, you can see, so let's look at the output to see if they have been treated properly or not. We can see that the minimum values are not that extreme anymore. But unfortunately, I think there is a positive value still in days employed, right? And the reason is, remember I told you that we use an ensemble technique with five different techniques. The config I chose was that at least 2 of those techniques have to call it an outlier for this to be flagged as an outlier, right? And what must have happened is that error that is still there must have appeared for a bunch of applicants. So there must have been, that error must have been repeated often enough in the data for 3 techniques to say, hey, this is not an outlier, right? So here, we can modify the config function, right? In this case, basically the min validation count, we can change from 2 to 1, right? So even if one technique calls it an outlier, we call it an outlier, and you can see that once we call it, it's gone. So that's an example of running outlier detection programmatically and treating it in one shot. So, and again, we only have half hour more. I want to take you through other stuff. So I just showed you outlier detection. We have exact same thing for IDness detection, biasness detection. All those functions all exist, right? Where you can go and you can automatically do them. But hopefully we were able to demonstrate some of the cool stuff that we believe. Yes.
So you mentioned it's an ensemble of different techniques.
Yes. It's things like, I even had, the percentile, standard deviation, the 5 different techniques, yeah.
Is there a way we can modify the config to, so for example, like you said, like if 2 of these techniques qualified as an outlier and be an outlier, we can change that to 1 or 3, whatever, but can we also specify if the percentile technique?
Yes, you can in the config file. In fact, I don't know if you'll have the time. After that, we can actually show you the YAML file through which you orchestrate and set it through that config file.
If you look at this also, you can specify lower what is your lower percentile, upper percentile. You can specify all of that.
Quite customizable.
Oh, it's very customizable. Yeah. And remember that this has evolved over years, right? So we saw it didn't work. So yeah. So now we'll move, I showed you EDA. So now we'll move on to feature identification and show you what I think is the coolest part of ANOVOS, right? Well, it is not that this is not cool, but it's still, you can write a paper on it, like academic paper on it. Now I'm going to show you something that's basically was the PhD of one of my best students. So we get into feature identification. The first step is candidate feature generation. Hey, what predicts, right? I'm trying to do credit risk. What predicts, right? It is completely ad hoc. Completely ad hoc. And basically what modelers do is they use guesswork and domain expertise, right? And most modelers typically are not experts at, the guy who is modeling travel insurance or the woman who's modeling, credit risk, graduated out of a CS program or data science program, goes there. They have no basis of understanding the domain, right? So this is what we've done. Right? By the way, so there is, for those of you who are like deep into this, so there are things called auto feature generators, right? So what you can do is you can use an automatic feature generator, and it generates, if you have, let's say, n attributes, it almost generates n factorial possible features. everything convoluted, everything square, cube, log, and that's horrible. I mean, I am a huge, because yes, it might generate something, attribute n times attribute m square root of and the log of that ends up being predicted of the target variable. Yes, it can happen, but it doesn't mean anything, right? You can't explain it. You don't know how stable it is. You have no clue why it happened. You just don't know if it's a function of that data set. So I'm a huge non-believer in automatic feature generation, but it exists, right? So this is what it's not. So what we have done is this, right? So we have built this component. We have built two components, the feature explorer and recommender, and a component called feature mapper. So the feature explorer, what that does is the goal is this. You go into the feature explorer and say, I want to model this. This is the outcome I'm seeking to predict. And the feature explorer outputs, tells you, hey, here are 27 features that you might look at, right? The way we have done it, Varun, if you will show that call. So basically you call the feature explorer call is the list feature by pair. There's a function in ANOVOS called list features by pair. Basically, you call it with two arguments, right? One argument is the outcome you seek to predict, and the second argument is the domain. So in this case, you could, and it can be very free form. Here we are showing you, where if you just go up slightly, I want to show that. We are saying I'm trying to predict credit risk in finance, right? You also say number of features equal to 10 to limit the number of features you're seeing, but basically you're saying, I want to predict credit risk in finance. You could have said, I want to predict creditworthiness in lending. You could have said, I want to predict loan default score in fintech, right? So it can be sort of super open-ended. And what we have done is, over the past many years, we have been creating what we call a feature corpus, right? So imagine that we have scanners that are scanning for documents both in academic and in trade literature about modeling, right? So right now, I think we have scanned through, 7.7 million documents or something like that, and it's continuously ongoing. And over time, we have not perfected, but we have definitely gotten better at interpreting those documents. All of those documents, in order to qualify, those documents have to be, how to predict churn in telecom, or how to predict something, right? And then we have gotten good at extracting features that ended up being predictive of that, right? So right now, we have created this massive feature corpus, which is continuously increasing, okay? And many of our users are adding to that as well, right? So there is a huge network effect. So that's what's those of you who are interested, you can go and you can just type in. In fact, we are thinking of making this available, like open on the ANOVOS website. We haven't done it yet. But it's a very, very cool thing. It basically generates feature labels that are predictive, and it's quite versatile, guys. Yes, I mean, you can fool it. I'm trying to predict the length of like tooth of tigers or something. It will fool it, or it won't. But for most enterprise use cases, you'll find matches. So that's the feature explorer. So Varun, if you and you can see that I call it and it outputs, loan status, income, housing, credit, blah, 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 blah. It sort of outputs a bunch of things, right? But these are still labels, right? Yes, I know that I should be looking at those labels, but I still need to create them. I still need to instantiate them. I need to manifest them to be used in a model, right? So how do I do that, right? So how do I use my data to create proxies for those, right? That's done by our mapper function. The mapper function is named very poorly for whatever reason. We should fix that. The matcher function is named the recommender, right? I have no clue why that is, but Dat Tran, a very young Vietnamese, very smart dude who codes this, has chosen to call it the feature recommender. I have no clue why, but I think if you show the function, yeah. So the way you call the map, and the purpose of the mapper is to say, use this attribute to create this feature. Okay. Now, you call the feature mapper with three arguments. An attribute description file. Basically, you tell the feature mapper, these are the attributes I have. You give it the data dictionary, right? So it's basically attribute name and an attribute description. A domain and an outcome. You repeat that. And the call to the feature the mapper is shown now. And you see the output. The output is 4 columns. It's tabular with 4 columns. The first 2 columns is simply the attribute description file. It's just repeating what you just fed it, attribute description. Rows 3 and 4 are the features, right? So basically you can interpret each row of this output has 1 attribute and 1 feature. And basically you can interpret this relationship that attribute composes that feature. So you would use that attribute to compose that feature, right? A very easy way to look at it, Vern, if you show that we also visualize this using Sankey diagrams, which I'm sure most of you know. So you can see, so it's basically nothing but a Vern, can you show the diagram? Oh, the arcs are sort of super thin. Yeah. So it's basically, it's a tripartite graph, right? I mean, attributes, features, and domains. Forget the domains for now. Basically, an arc from an attribute to a feature is basically telling you that attribute composes the feature, right? I won't get into this, but in our terminology, a feature can be basically what we call a molecular, atomic feature, which is just 1 attribute, or it can be a compound feature, which is made of multiple attributes. You can see that as well. What's the in degree into the node, into the feature node? You can. So if more than 2 arcs come into a feature node, that basically means it is more than 2 attributes. And of course, if no arcs come into a feature node, that's an indication that, hey, I can create this out of my data. And then of course, you have to actually create, and we have to create the data set attributes of our own. Below we show you sort of the code to create those features. You had the codes, right?
Yes.
Yeah. So generate the rest. So we had the codes, no, Varun? Thought we had the codes. Anyway, so I thought we had the codes that generate the features here as well. I'm not sure we do or not. So again, this I showed you an example of how we address a cold start problem. Now, of course, there may be cases when the modeler possesses knowledge already, right? And she says that, look, I know this feature is going to work, so I want to create this feature. So that's obvious. So we provide basically a 4GL programming interface for the modeler to code those features. So you can use a SQL-like language to code those features. For instance, a new feature called income per person, can be calculated using sort of amount income total divided by count of family members, right? There is also another feature called feature transformation, where you can apply base math functions, right? Square, log, and sort of super easy, right? For instance, it is very easy to see that, hey, if I just plot an attribute and the target variable, we can see the relationship is not linear, right? And we can easily see that. You can apply a square transformation to that, saying that, hey, would an exponential transformation make it a better fit? There are, and again, for instance, I showed you that there are a bunch of things that are very skewed, right? So for instance, we showed you where the 99th percentile and the max value was very high, which means it's a long tail kind of distribution, right? So you can apply log, because log will shorten tail. So we offer a set of functions to do that as well. And so now basically we have come, Vern, if you show the slide. So at the end of this step, so we now have your candidate feature set, right? So your candidate feature set typically, and this is we recommend this, so canonically, so of 3 things, right? The first is the feature that was suggested by the feature recommender, those. Second, You might have your own custom features, those. And the third thing we recommend, guys, to everyone is that all my base attributes can be features themselves, often, right? So add those as well. So it's my feature explorer recommended stuff, my custom stuff, and all my base attributes. That becomes the canonical sort of candidate feature set. And now sort of we get into the final state of feature engineering. Clearly, we're going to prune this state, right? So eventually, the model-ready features is going to be some subset of this. So we want to prune this. So we prune this using a set of checks, right? And we'll show you how Annovos automates those checks, right? So we do 5 checks. The first is stability. How stable are these features? So I described to you the notion of stability before, but those were attribute stabilities. Of course, now I'm doing feature stabilities. So Annovos has a feature stability function. So Annovos, basically, you can estimate feature stability. And when you invoke this function, you can see that there's a and we're showing it in the notebook. So you can see that there's a difference, right? So for attributes, for the base attributes, features a single value, 1, 2, 3, 4. Here, feature is shown as a range, a min and a max, right? So and especially that becomes important because there are features that are composed of more than one attribute. Or a feature is, clearly, if a feature is a unit attribute itself, the attribute stability is a feature stability. When it's not, when it's a transformation of that attribute, it's basically, we express it as a range. And I made some notes here. For instance, days employees minus days birth, you can see, is the most unstable feature, right? You can see the range, and we should consider dropping it, right? It's not a good feature. So and you can analyze the same thing. So now the second check, cardinality check. So all of you know that most learning techniques don't deal with high cardinality very well. So we will reduce cardinality. For instance, so we can basically we'll show you the example of something called an outlier categories function. One of the classic ways of reducing cardinality is for categorical attributes that have high possible values, right? So you can apply the outlier categories function to limit the number of classes of categorical features. The underlying logic that we follow is that if there is a high cardinality categorical attribute, we will keep taking them. Let's say there are 100 categories, right? You first organize them in order of frequency. Category I, highest frequency. Category J, second, and so on. And then I'll keep taking them until I've covered 95% of my values. And then everything else I'll say other, okay? But what might happen is that even then, that may be too much. So if that happens, so we have found, and again, this is, you can argue with this, but based on our experience, we have found that more than 15 is sort of the cutoff, right? So what we'll do is that we'll take up to 14, and if that doesn't cover 95%, we would still put everything else as others, right? So that's the, and here we are showing you, in this data, in the Kaggle data set, organization type contains sort of 57 unique values before treatment and 15 unique values after treatment, right? Third check, missing values. Here, for the features, the way you handle missing values is you do both columns and rows. We have a function called null columns detection that does missing value for columns. We have null rows detection that does missing value for rows. So if we call the null columns detection function, and we can say just throw everything away that is greater than 60% missing values, that's what we've used. And for row-wise null values, I think what happened was that after checking with null rows detection, all rows have fill rate less than 50%, so we'll proceed without treatment. Okay. So now, I have what falls in between. So now I will impute the rest of the missing values. Okay. So imputation, one of the hardest and the most, something that really can impact the quality of your model. Imputation can of course be done manually, right? Through a number of techniques that we provide in Annovos. But one of the cool features, again, is that we support auto imputation. so basically which automatically finds the optimal imputation method by evaluating 5 different methodologies. And the methodologies we use are mean, median, k nearest neighbors, iterative imputer, and matrix factorization. So, and basically the optimal value is the method that minimizes RMSE, right? The root mean square error. Basically we do that, and the best value, best one is selected, right? Of course, you can call iterative imputer by itself. You can call matrix factorization by itself, but this works very well for us, right? Fourth test, got to encode categorical attributes because most learning techniques cannot handle categorical. You're going to change them to numerical. So we offer encoding, and we offer 3 kinds of encoding in Anofos, right? The one that we like the best, and I think the team, and here, I never build a model myself, so but the one I know the team likes the best is, classic CS professor. I talk, but I don't do anything. So weight of evidence, right? So that's I think the team likes the best, and effectively the technique is that for each attribute, the positive event rate for the categorical value is used as the encoded numerical value. Of course, the values could be all over the place. So you normalize, right? You take the max, min, 0, 1, and then you normalize. And I think we offer 2 other commonly used methods as well, label encoding and one-hot encoding also. So you can have all of those. And then final, we come to, yes?
Can you say the name of the first one again?
Label encoding.
The one that you said.
Oh, weight of evidence. Yes, yeah, WOE, yeah. Then final step, I got to reduce dimensionality, right? Because techniques don't handle high dimensionality very well. So 3 ways that we offer in Anofos: variable clustering, which we talked about. So super simple, run it, see the cluster, pick one, right? That reduces dimensionality. IV calculation is another common way to reduce, but you can remove features with low information value. For instance, if you call IV calculation, you can see that the binary features whose names start with flag have very low, mostly have 0 value, so we can drop them. And then finally, something that also is latent features. We offer you latent features as well. So in Anofos, latent features can be generated using either PCA, principal component analysis, or autoencoder, TensorFlow, autoencoder implemented in TensorFlow. In this example, we applied on the features related to amounts of money, and according to the results, sort of four latent features are created, right? So that's it. So that's how we do it. And then, Varun, if you show, so that's sort of the, and basically what I also showed you, which is not really part of the package, but we show you a best practices flow of feature engineering as well, right? I mean, that's sort of, that orchestration. And then, Varun, if you'll show the final, yeah. So anyway, we have something where Varun has a slide where we're showing you the final model-ready features. So that's it. So hopefully this was useful.
I just wanted to know if you've got that documented anywhere, the flow of the feature selection or engineering for like reference.
Varun, yeah, I think.
Sure, we can. It's not formalized, but we can create a deck and we can.
That's because I think that's what I found quite helpful in this session is organizing the process.
Sure.
Thanks.
But if you'll put the YAML file, yeah, those are the final features. If you'll put the YAML file on, that can also be super helpful. So some of this orchestration can be done through YAML, right? Mm-hmm. So it'll show you through the config file.
I just want to make sure I understand using the terminologies. Attributes, which are just native to the data, features, the atomic features you're talking about, it's the exact same thing as
attributes. So, and that's a very good point because there's heavy overloading of the word feature, right? Because people will say attributes as features as well. But we typically say attributes is what you ingest, and then features is what you produce. But those attributes could be features as well, as I yeah. Was this useful? I mean, I hope this was not super boring. Yeah.
Thank you so much for the presentation. Also, I wanted to ask about the features for unstructured data, like text. or this is based on, for example, initial assessment and feature engineering for text?
So Annovos right now only supports numerical and categorical, and it only supports tabular and time series data sets, right? It will evolve. It does not, if you wanted to do text modeling, especially, in fact, I don't think Annovos will ever support things like image and so on and so forth, right? But we feel that there is a large enough number of people who are doing modeling. But yes, text we will eventually, yes.
Yeah. Thank you.
Yep, and the config file is up. So
Yeah,
you
so
can use this to automate your workflows. You can specify all the functions, what percentiles, thresholds you want, and you can use this to automate your data pipelines.
And this config file right now is manual in the sense that what we are also soon, if you kind of just kept doing a notebook, this will be generated automatically as well.
Yep.
Yes.
If there's something, if some of the features have a lateral drift, like interest rate level, so what do we need to do?
So drift and stability is intrinsic, right? I mean, the data is coming from a real world distribution which you cannot impact. But the point is that if there is, so we have found as a rule that the less drifty a feature is, the more resilient a model it produces, right? So the classic issue that we run into is when you have a feature that you find is very predictive, right? It's predictive, you build a model, but the predictive value of the model, the predictive accuracy of the model is very high, but the features you use to build the model are not very stable. So what happens is the model soon degrades, right? So now at least our customers are almost saying, I would rather build a good model that is resilient than a fantastic model that will screw up in 2 weeks, right? So we've seen that drift and stability can be a huge anchor for building resilient models in 2 ways. One is you try to build a model with stable features, and you know the model is not going to drift often. Or you might see that a feature is so attractive, the model is so powerful, so accurate, you would still do that, but you would know that, hey, this might drift, the model might not be resilient. So you can monitor it more. At the end, your MLOps resources becomes a huge constraint because you're spending money. You can allocate more, you can skew the resources to monitor models that you think might drift.
Hey, great presentation. We were looking for a tool like this in Spark, so we'll definitely take a look at it. I was a bit confused by the feature recommender. So from what I understood is you say, hey, I'm in this domain and this is the type of problem, and then it suggests features.
Correct. It says labels to you, yes.
Okay, and then what was the other part? There is another part after that. Could you explain that part again?
So the idea was, so in this problem, for instance, right, it suggested a feature called household income, right? That was one of the suggested features. So all that tells you is that household income of the applicant has proven predictive of that applicant's creditworthiness, right? But you still need to instantiate that feature from the data you have, right? So there are 2 steps. One is, what are the feature labels that I need to work with? And then how do I need to create them? Those are the 2, so from the data I have, those are the two parts.
So it essentially tries to figure out, like, from your attribute list, which one corresponds the most to the recommended, but just based on the name.
And it's based on basically semantic and textual analysis, right? So it's looking at attribute description, looking at that, and yeah. You should try it. We have a lot of people that are.
Hi. Yeah, wonderful talk. I kind of stumbled in a little late, like 20 minutes late. But yeah, just curious. So I'll give you some context here. We have a recommender system right now, like my company, that's like kind of like our flagship product. We struggle a lot with, I think, evaluation. We look at a few offline things like map at K, that sort of thing before we productionize stuff. Future goals, A/B tests, et cetera, et cetera. But what do you think are like the biggest misses with Rexis in specific? Maybe you've touched on this earlier in the talk, so sorry if I've missed it. But in general, like companies like us should be looking more into. Not sure if that makes sense, but yeah, just from a learning standpoint.
So I would love to tell you that Anovos can help you evaluate, but it really cannot, right? I mean, that Anovos is not an evaluation model. But I'm curious, again, if I put my sort of pure technical hat on, why? I mean, the classical sort of, evaluation of recommender systems is pretty well understood, right? So those techniques are not,
Yeah, but like there's always
I'm looking at historical data, see what you would recommend, see how it corresponds. Those are like precision recall and all that are not.
No, but there's always that disconnect between what the customer sees and how they behave versus what we have like on offline metrics, say, right? And that's like you want to really converge that as much as possible. If that makes sense. Yeah. But yeah.
So let's talk briefly outside, but I'm not going to say that I am hopefully I'm self-aware and not. This is a place I'm not sure that I have a normative suggestion for you, but I'm curious if you look at, I've done some work in recommender systems a long time ago. Normally though, so for instance, a student of mine works in Amazon with a record. So basically the way the test is pretty simple, right? They look at, hey, this was the recommendation. So, and they see how the customer reacts, right? So if you design a simple metric, once a customer is recommended something, how often does that user act on that recommendation, right? So one recommendation technique would have the user acting on that recommendation P% of the times. A second recommendation technique would have the user acting on that recommendation Q% of the time, and whichever is greater would be the better technique. That's typically how recommendation techniques have. That's what I would think.
Yes, I'm trying to do it here. It's taking a little bit of time. Are you able to demo just the list of industries and some of those use cases?
Sure. You mean the features, right? The feature explorer.
Literally just this list _ all industry function, just to see if something's relevant. I'm just not able to do it here right now.
Sure. I mean, you can, if you've downloaded it, you can do it yourself. Just run the function and get it out.
Okay.
I'll
follow up with you after.
Sure.
Yeah.
But I would think that the use of Anovos for you guys would be in preparing the data for the recommendation, right? You imagine that this entire data hopefully streaming in from whatever the system the customers are interacting with, and then those are becoming the input into the recommendation, the modeling. So that's where we would be, So one of the key things in recommendation is selecting the features that are predictive, right? So that's where this would work. We would think we would, yeah.
Thank you.